Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi and we are continuing with the properties of acids, and already we have seen two properties. The first one being the reaction of dilute acids with metals, which we say that the products are salt and hydrogen gas. The second property, we discussed the reaction of dilute acids with metal carbonates and hydrogen carbonates. So we are going to look at more equations on the reaction of metals or metal carbonates with dilute acids. So more equations on the reaction of dilute acids with metal carbonates and hydrogen carbonates. So generally we say that if you take a metal carbonate plus an acid, we will get a salt, we'll get carbon 4 oxide, and we'll also get water. So three products there: metal carbonate or hydrogen carbonate. So in each of the cases, we must get three products: the salt, there must be carbon 4 oxide, there must be water. And then the test for carbon 4 oxide is that the gas forms a white precipitate with lime water. Lime water is calcium hydroxide. When you bubble carbon 4 oxide there, you get a white precipitate. And then if you continue bubbling more carbon 4 oxide, the white precipitate will dissolve. So you can say that the white precipitate dissolves in excess carbon 4 oxide, dissolves in excess carbon 4 oxide due to formation of calcium hydrogen carbonate, which is a colorless solution. So that is a summary of what we learned in our previous property. So we are going to have the examples of equations. Examples of equations between a metal carbonate with an acid or a hydrogen carbonate with an acid. So let's say we take magnesium carbonate plus dilute sulfuric acid. So we'll get magnesium sulfate as the salt, plus carbon 4 oxide must be there, plus water. So we saw that there are three products: the salt, carbon 4 oxide and water. The salt that we get from sulfuric acid must be a sulfate. And because it's magnesium that we are using, it will be magnesium sulfate. Another example if we have calcium carbonate plus dilute nitric acid, then the salt will be calcium nitrate. Of course, plus carbon 4 oxide, that one must be there, plus water. So that's another equation. So the type of acid that we use is the one that determines the type of salt. If it is nitric acid, we get nitrate. If it is sulfuric acid, we get sulfate. If it is hydrochloric acid, we get chloride. So we can take another lithium carbonate plus hydrochloric acid. So here you'll get lithium chloride. Plus carbon 4 oxide must be there, plus water. So basically, that's how the equations are. So in those three examples, we have used a metal carbonate plus an acid. Let us now use a hydrogen carbonate. So for example, sodium hydrogen carbonate plus sulfuric acid. So we'll just get sodium sulfate. So the products are just the same, sodium sulfate. Sodium, then sulfuric acid, we get sodium sulfate, plus carbon 4 oxide, plus water. So there is no difference between metal carbonates and hydrogen carbonates. They just behave the same way. We get three products. There must be a salt, there must be carbon 4 oxide and water. So salt here is sodium sulfate, carbon 4 oxide and water. And at this point, we don't use the word carbon dioxide. We use the word carbon 4 oxide, though it is the same thing. But the acceptable way of naming the gas is carbon 4 oxide, not carbon dioxide. It was previously referred to as carbon dioxide, but now it's carbon 4 oxide. So that being the case, we can have an assignment on that. So the first question, state two observations made when a dilute acid reacts with a hydrogen carbonate. And number two, state the test for carbon 4 oxide gas. 3, complete the equations below. Zinc carbonate plus sulfuric acid, sodium hydrogen carbonate plus hydrochloric acid. So we'll stop there. Until next time, goodbye.